The biggest shift isn't coming from AI. It's emerging from something even more enigmatic: quantum computing. A technology so bizarre, even scientists label it unpredictable. But here's the startling truth. It's already here. Governments are quietly racing behind closed doors. Corporations are investing billions into unseen experiments. While you're focused on everyday tech advancements, something profound is reshaping the very fabric of reality. These are the secrets they prefer to keep hidden. Let's begin with the first concealed truth. Quantum supremacy might already be a reality. Back in 2019, Google's quantum chip changed the game. It solved a calculation in just 200 seconds, a task that would take classical computers millennia to complete. That moment revealed something both terrifying and powerful. Quantum computers were no longer a fantasy. They were operational. But right after that, there was silence. IBM contested the claim, suggesting it could be simulated. Then China quietly entered the scene, developing their own machines. And those tests? They're just the beginning. They succeeded, but barely anyone noticed. Why? Because true quantum dominance is a threat. If a nation builds a stable quantum machine first, it could dismantle today's encryption overnight. Your passwords, your messages, your secrets, all gone. Even military communications would be exposed instantly. That's why governments keep quiet. Too much is at stake. The race for supremacy has turned into a global secret war. Now, let's reveal the second truth. Software, not hardware, is the real battlefield. Everyone imagines shiny machines in sterile labs, but the true competition lies in the code that drives them. Quantum computers speak a language we're just beginning to understand. They navigate superposition, entanglement, and probability waves. To harness their power, scientists are crafting unique frameworks. IBM has Qiskit, Google has Cirq, and Microsoft has qubits. These aren't just programs, they're the new quantum operating systems. Logic operates beyond just ones and zeros. It embraces both. Coding for quantum feels like teaching chaos to follow rules. The first stable framework in this realm will dominate the future. Imagine controlling quantum particles and their interactions. Writing commands that shape the future is happening now. This process is silent, invisible, and relentless. Billions are being poured into these unseen digital advancements. The hardware may look impressive, but the real battle is in algorithms. And here's a crucial insight. Quantum computing threatens cryptography. Every encrypted message relies on complex, unsolved math. These equations safeguard banks, governments, and personal data. But quantum power doesn't adhere to those constraints. It can solve problems that seem impossible in mere seconds. This means security is merely an illusion we cling to. Your encrypted files could already be in the hands of spies. They're waiting for quantum machines to crack them open later. This strategy is known as harvest now, decrypt later. The data you send today could be exposed tomorrow. Governments are quietly racing behind closed doors. Corporations are pouring billions into invisible experiments. And while you're watching everyday tech evolve, something deeper is rewriting the laws of reality. These are the secrets they don't want you to know. Let's start with the first hidden truth. Quantum supremacy might already be real. Back in 2019, Google's quantum chip changed everything. It solved a calculation in 200 seconds, a problem classical computers would take millennia to finish. That moment proved something terrifying and powerful. Quantum computers weren't a dream anymore, they worked. But right after that, silence. IBM challenged the claim, saying it could be simulated. Then China stepped in quietly, building their own machines. And those tests, they succeeded, but were barely mentioned anywhere. Why? Because true quantum dominance is dangerous. If a country builds a stable quantum machine first, it can break today's entire encryption system overnight. Your passwords, your messages, your secrets, gone. Even military communications could be exposed in an instant. That's why governments choose silence. Too much is at stake. The race for supremacy has turned into a global secret war. Now let's reveal the second truth. Software, not hardware, is the real battlefield. People often imagine shiny metal machines in sterile labs, but the true competition lies in the code that drives them. Quantum computers speak a language we've never encountered before. They navigate superposition, entanglement, and probability waves. To harness their power, scientists are crafting unique frameworks. IBM has Qiskit, Google has Cirq, and Microsoft has qubits. These aren't just programs, they're the new quantum operating systems. Right now, developers are training these systems to think in new ways. Traditional programming stumbles when uncertainty reigns supreme. Quantum logic doesn't rely on ones or zeros, it embraces both. That's why coding for it feels like teaching chaos to follow rules. But whoever creates the first stable framework will seize it all. While buzzwords like AI and blockchain dominate the conversation, quantum computing is quietly reshaping the very foundations beneath them. Banks, governments, and militaries are all on borrowed time, unaware of the silent countdown that has begun. Few truly understand the implications of this shift. This is just the beginning of a new era. In the next part, we'll explore the global race for quantum control and how nations are turning science into strategy. What's coming next will redefine power itself in ways we can't yet imagine. Many believe that more qubits equate to more power, but that's a dangerous illusion driving the industry. The reality is, it's not about quantity, it's about quality, stability, and connection. Every company boasts about their massive qubit counts, throwing around numbers like 400, 1,000, or even 2,000. But here's the catch. Most of those qubits don't work properly at all. They exist, but they can't hold information long enough to be truly effective. The real measure isn't how many qubits you have, it's about how long they stay stable and connected. That's what we call quantum volume, a hidden metric that reveals who's truly ahead. A few stable qubits can outperform 1,000 weak ones. IBM's Condor chip hit 433 qubits last year. It sounded revolutionary until researchers took a closer look. Many of those qubits couldn't maintain coherence at all. They were basically silent spectators in the quantum race. That's why companies like Google and Atom Computing are shifting to modular systems. They're creating smaller, smarter designs, linking stable processors together like neurons, not bigger but smarter. That's the new race. Now here's where the illusion deepens. Quantum computing sits in what experts call the hype cycle, a period where excitement outpaces reality. It's the same stage AI went through a decade ago. Investors are pouring billions into startups with big promises, but many can't deliver what their pitch decks claim. In 2021, quantum startups were media darlings. By 2025, many were merging or disappearing quietly. Reality hit hard. Error correction is brutal. Building stable quantum systems takes time, not slogans. The hype wave has started to crash. What remains now is pure survival mode. Analysts call this the trough of disillusionment. It's when the dream looks distant and investors lose faith. But history shows that's when real breakthroughs happen. Behind the silence, giants like IBM and Quantinuum are quietly publishing genuine progress. Each paper is a small spark in the darkness of doubt. IBM's roadmap predicts utility-scale quantum systems within 2 years. That means computers capable of solving useful, real-world problems. No more demos, no more theoretical models. Actual performance. The noise may fade, but the truth is brewing in the background. Because revolutions don't shout, they whisper before they explode. Now, let's talk about quantum advantage. The holy grail every lab is chasing. It's when a quantum computer outperforms the fastest classical one. Google claimed it in 2019 with its Sycamore experiment. The media exploded, calling it a new era of computing. But there was one problem. It didn't matter in the real world. The test solved a random math puzzle with no application. It was impressive, but ultimately meaningless for humanity. Since then, small victories have emerged in the quantum realm. IBM simulated a lithium hydride molecule with quantum precision. Quantinuum cracked chemistry problems beyond classical methods. Yet, even those breakthroughs needed support from traditional systems. The truth is, quantum advantage exists, but it's fragile and rare. We've touched it, but we haven't mastered it yet. Every small leap brings us closer to a tipping point. One day, one machine will cross the threshold permanently, and from that moment, nothing will ever be the same. Every encryption, every database, every simulation will be transformed. That's the day quantum stops being theory and becomes destiny. But until then, the market plays a dangerous game. Money is flooding in faster than progress can handle. Consultants call it quantum inflation, when marketing grows faster than physics. Dozens of startups promise quantum breakthroughs they can't prove. Analysts warn a quantum winter is coming soon. Just like the dot-com bubble or the crypto collapse, only the strongest companies will survive. But here's the twist. Failure still fuels progress. Each collapse leaves behind data, materials, and smarter algorithms. Even when a lab closes, its discoveries push others forward. That's the strange beauty of scientific collapse. Every dead end is a blueprint for the next success. So, yes, the quantum dream might slow down, but it's not stopping. Behind every hype headline lies a real discovery waiting. And when the dust settles, only truth will remain. The question isn't if quantum will take over, it's when and who will hold that power first. In the next part, we'll uncover the final truth, why quantum won't replace classical computers, how both will merge into one unstoppable system, and why that union could unlock a new era of intelligence itself. Part 4 will reveal the endgame of the quantum revolution. Here's the biggest misconception of them all. People think quantum computers will replace classical ones. They imagine a world where everything turns quantum. But that's not how the future will unfold. The real destiny is hybrid computing, collaboration, not domination. Quantum machines are built for extraordinary problems. They thrive where classical systems reach their limits. Massive simulations, impossible optimizations, molecular predictions. That's their battlefield. But your daily systems, data storage, browsing, communication, those still belong to classical machines. Think of it like a partnership of geniuses. Classical computers provide logic, structure, and speed. Quantum computers bring creativity, intuition, and chaos. Together, they form the most powerful alliance ever imagined. IBM calls it quantum-centric supercomputing. It merges quantum processors with AI and high-performance systems. The result is a single architecture sharing the workload. Google and Microsoft are already testing these hybrid frameworks. In their cloud platforms, Quantum and classical tasks run side by side. That's called coprocessing, a union of precision and possibility. So when quantum power fully arrives, it won't replace what we know. It will amplify it. Classical systems will handle structure and logic. Quantum systems will handle the impossible. And together, they'll reach solutions beyond human imagination. Now imagine what that means for the world. A single hybrid system could design new medicines instantly. It could simulate the universe molecule by molecule. It could predict global markets with uncanny precision. It could solve climate equations we've failed to understand for decades. This is what's waiting beyond the horizon. But let's pause for a moment and ask, are we ready for that kind of power? Because once we unlock it, there's no turning back. Quantum systems won't just process data, they'll understand it. They'll simulate thought, decision, and reality at once. It's not just faster computing, it's a new form of intelligence. Experts believe the first quantum AI fusion is inevitable. Artificial intelligence thrives on computation and pattern recognition. Quantum systems multiply those patterns infinitely. Combine them, and you create a machine that learns reality itself. One that doesn't just compute answers, it predicts outcomes. That's the real endgame of this revolution. Not faster hardware or bigger qubit counts, but an intelligence that evolves with the universe's own logic, an AI that sees possibilities before they happen. Governments know this, and that's why they're protecting their progress so fiercely. Quantum power could reshape economics, defense, even civilization. Imagine nations using it to predict wars before they start, or to model global economies decades into the future. Whoever holds this intelligence won't just rule technology. They'll rule understanding itself. And yet, the scariest truth remains. Quantum power won't belong to everyone. At least, not at first. Like every revolution, it will start in secrecy. Corporations and governments will hold the keys, and the rest of the world will watch in awe and fear. But change always finds a way to spread. Just like classical computing once did, quantum power will eventually escape the labs. It will reach universities, startups, and innovators worldwide. And that's when the real transformation begins. One day, your smartphone might whisper quantum code. Your AI assistant might predict reality in real time. Your medical scans might be decoded by quantum patterns. Every field, every mind will evolve alongside it. It will no longer be quantum technology. It will just be technology. So, what started as a scientific curiosity will end as the next stage of human evolution. Quantum computing isn't just about machines. It's about the human desire to understand everything, to see beyond the possible, and build what once seemed divine. And as we enter this new era, one truth stands above all. The revolution won't be televised. It'll be simulated. The next leap of intelligence won't happen in our hands. It'll happen in the quiet pulse of quantum code. The future isn't coming. It's already calculating.